Azure Cache for Redis is a fully managed in-memory cache that enables high-performance and scalable architectures. It is based on the popular open-source Redis cache. By storing data in memory, it allows for faster data retrieval compared to traditional databases. This makes it ideal for use cases such as session storage, real-time analytics, and caching frequently accessed data. In this presentation, we will explore how to configure cache and expiration policies for Azure Cache for Redis, ensuring optimal performance and resource utilization. Caching is a critical component in modern application development. It helps reduce the load on databases, decreases latency, and improves the overall user experience. By temporarily storing frequently accessed data in memory, applications can quickly retrieve this data without repeatedly querying the database. This not only speeds up response times, but also reduces the cost associated with database operations. Azure Cache for Redis provides a robust caching solution that integrates seamlessly with Azure services, making it an essential tool for developers. Expiration policies in caching determine how long data should be stored in the cache before it is considered stale and removed. These policies are crucial for maintaining the freshness of data and managing memory usage effectively. In Azure Cache for Redis, you can configure different expiration policies to suit your application's needs. Common policies include absolute expiration, where data expires after a fixed time, and sliding expiration, where the expiration time resets with each access. Choosing the right policy ensures that your cache remains efficient and up to date. To start using Azure Cache for Redis, you need to create a cache instance in the Azure portal. Begin by navigating to the Azure portal, selecting Create a Resource, and searching for Azure Cache for Redis. Follow the prompts to configure the basic settings, such as the cache name, resource group, and pricing tier. Once the cache instance is created, you can access it through the Azure portal, where you can manage settings, monitor performance, and configure expiration policies. Proper setup is the first step towards leveraging the full potential of Azure Cache for Redis. Configuring expiration policies in Azure Cache for Redis involves setting the appropriate time-to-live (TTL) values for your cache data. This can be done programmatically using Redis commands or through the Azure portal. For example, you can use the expire command to set a TTL for a specific key, or the setX command to set a value and expiration time simultaneously. Additionally, you can configure default expiration policies for all keys in the cache. By carefully setting these policies, you can ensure that your cache remains efficient and that stale data is promptly removed. Redis provides several commands to manage expiration policies effectively. The expire command sets a TTL for a specific key, while the TTL command returns the remaining time to live for a key. The persist command removes the expiration from a key, making it persistent. Additionally, the setX command sets both the value and expiration time for a key in one step. These commands offer fine-grained control over your cache's expiration policies, allowing you to tailor the caching behavior to your application's requirements. Understanding and utilizing these commands is essential for effective cache management. Monitoring the performance of your Azure Cache for Redis instance is crucial for ensuring optimal operation. Azure provides several tools and metrics to help you keep track of cache performance. Key metrics include cache hits and misses, memory usage, and network bandwidth. By regularly monitoring these metrics, you can identify potential issues, such as high miss rates or memory pressure, and take corrective actions. Azure Monitor and Redis Insights are valuable tools that provide detailed insights into your cache's performance, helping you maintain a high-performing and reliable caching solution. Despite its robustness, you may encounter issues with Azure Cache for Redis that require troubleshooting. Common problems include high latency, frequent cache evictions, and connectivity issues. To troubleshoot these issues, start by examining the cache metrics and logs available in the Azure portal. Look for patterns or anomalies that could indicate the root cause. Additionally, ensure that your cache instance is appropriately sized for your workload and that your expiration policies are correctly configured. By systematically analyzing the available data, you can identify and resolve issues, ensuring smooth operation of your caching solution. Optimizing the performance of your Azure Cache for Redis involves several strategies. First, ensure that your cache instance is appropriately sized for your workload. Under-provisioning can lead to high latency and frequent evictions, while over-provisioning can result in unnecessary costs. Second, fine-tune your expiration policies to balance data freshness and memory usage. Third, consider using advanced Redis features, such as data partitioning and clustering, to improve scalability and performance. By implementing these optimization strategies, you can maximize the efficiency and effectiveness of your caching solution. Azure Cache for Redis offers several advanced configuration options to enhance its functionality. These include data persistence, which allows you to save the in-memory data to disk, and geo-replication, which enables you to replicate data across multiple regions for high availability and disaster recovery. Additionally, you can configure Redis modules to extend the capabilities of your cache, such as adding support for search and graph queries. By leveraging these advanced options, you can tailor your caching solution to meet the specific needs of your application and ensure high performance and reliability. Securing your Azure Cache for Redis instance is paramount to protect sensitive data and ensure compliance with regulatory requirements. Start by configuring Network Security Groups (NSGs) to restrict access to your cache instance. Use Azure Private Link to enable private connectivity from your virtual network. Additionally, enable SSL/TLS encryption to secure data in transit and configure Redis authentication to control access to your cache. Regularly review and update your security settings to address emerging threats and vulnerabilities. By following these best practices, you can safeguard your caching solution and maintain a secure environment. To illustrate the practical application of Azure Cache for Redis, let's consider a case study of an e-commerce platform. The platform uses Azure Cache for Redis to store session data, product catalog information, and user activity logs. By implementing caching, the platform significantly reduces database load and improves response times, providing a seamless user experience. The team configures expiration policies to ensure that session data is promptly removed after user logout, and that product information is regularly updated. Through careful monitoring and optimization, the platform maintains high performance and reliability, demonstrating the value of Azure Cache for Redis in a real-world scenario. In conclusion, configuring cache and expiration policies for Azure Cache for Redis is essential for optimizing application performance and resource utilization. By understanding the importance of caching, setting up your cache instance, configuring expiration policies, and monitoring performance, you can ensure that your caching solution meets the needs of your application. Additionally, by following security best practices and leveraging advanced configuration options, you can enhance the functionality and reliability of your cache. As a next step, consider exploring the Azure documentation and hands-on labs to deepen your understanding and gain practical experience with Azure Cache for Redis.